All right, guys, today we're going to take a look at right triangle trigonometry. So this is a way for us to solve for sides or angles depending on what we're given in the triangle. The first thing that you see here is showing you what these trig ratios are. We have three different trig ratios that we are talking about: sine, cosine, and tangent. We usually abbreviate those as SIN for sine, COS for cosine, and TAN for tangent. Now, there are some important things here as far as the ratios. This ratio is depending on what angle you're looking at. Okay, so whenever you are trying to write a ratio, whenever you're trying to figure out what you're looking at, always look in terms of the angle. Okay, and we're talking about the two acute angles that are in the right triangle. Okay, so we never use the right angle to figure out any of these sides. Okay. In the triangle given, we have an angle marked as theta here. If you look at this angle down in the corner, okay, so we're looking at this angle here. If we look at this angle, opposite this angle is this vertical side. Notice it's already labeled opposite. And then adjacent to this angle is this horizontal piece. And then, of course, hypotenuse is still the side that's across from the right angle. Now, we can write our ratios based on that. Sine, if you take a look over here on the right, sine is opposite over hypotenuse. So sine is the ratio of the opposite side over the hypotenuse. Cosine is the ratio of the adjacent side over the hypotenuse. And tangent is the ratio of the opposite side over the adjacent side. Now, a lot of times, a quick way to remember, notice written up here, we call this SOHCAHTOA. Okay, it's a quick way to remember those ratios because we said sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So SOHCAHTOA is a quick thing to write down on your paper so you can remember which ratio goes with which. Okay, now next I want to take a look at writing these ratios. Okay, so if we're not going to solve for anything, we're not going to find anything yet. All we're doing right now is going to write out what these ratios actually are. So if you take a look at this picture given, first we have sine, cosine, and tangent of angle t. So we're going to start out by looking at angle t. Okay, that's what we're starting with. Sine of angle t. Okay, well, we said sine, if you quickly want to write it down just so you remember. So, okay, so sine is opposite over hypotenuse. If we look at angle t, the side opposite angle t is 7, and the hypotenuse is 25. So sine of angle t is 7 over 25. Cosine of angle t, well, cosine is your adjacent over hypotenuse. So cosine of angle t is adjacent side, which is 24 over hypotenuse 25. So 24 over 25 is the cosine of angle t. Now, tangent of angle t, take a look at angle t. Tangent is opposite over adjacent. So if we look at angle t, the side opposite is 7, adjacent is 24. So 7, whoops, here we go. 7 over 24 is the tangent of angle t. Now, I'll switch colors for this. Now we want to look at angle C. Remember, we only use these for the acute angles in the right triangle. So now we're looking at angle C. We want the sine of angle C. If we look for opposite over hypotenuse, looking at angle C, the side opposite is 24, and then hypotenuse is still 25. So opposite over hypotenuse would be 24 over 25. Now look at cosine of angle C. We need adjacent over hypotenuse. So looking at angle C, adjacent would be 7, and hypotenuse is still 25. So cosine of angle C is 7 over 25. And then last, we want tangent of angle C. Looking at angle C, we need opposite over adjacent. So the opposite side would be 24, adjacent would be 7. The tangent of angle C is 24 over 7. Okay, now Right now you're looking at this probably going, okay, well, this is great, but how does this help me? How does this let me figure out anything as far as figuring out sides or angles? And that's what we're going to get to next. The way that we can use these, we can set up ratios based on what we're given in a triangle and what we want to find in order to solve for a side or an angle. So let's take a look at what I'm talking about. Let's say, take a look here. We have a triangle given to us. We know one of the angles is 60 degrees, okay? And, excuse me, we want to solve for x, which is one of our sides. So now we already know special right triangle rules, so we could figure this out without trig, but I want to show you this with one of the special right triangles so that you can see that trig works as well, okay? And trig will work with every right triangle, okay? Your special right triangle rules only work for 45, 45, 90, or 30, 60, 90, whereas trig works with any right triangle. So let's take a look at this one. Let's write it, let me change back to blue. So we have this angle of 60, so that's our reference point. We want to find x, and we have a hypotenuse of 11. So let's take a look. Looking at angle 60, which is the one we are given, x would be adjacent, and 11 is your hypotenuse. Okay, so let's think about what ratio, and again, if it helps you, make sure to jot it down. Okay, SOHCAHTOA. Now, which ratio uses adjacent over hypotenuse? If we take a look, that would be cosine. So we could write an equation, the cosine of the angle. The angle always goes with the trig function. So you're always going to have sine, cosine, or tangent of the angle. So cosine of 60 degrees is equal to, remember, it's adjacent over hypotenuse. So adjacent, which is x, over hypotenuse, which is 11. Now, we want to solve for x, so we would multiply by 11 to get rid of that. Okay, so now we need to do 11 times the cosine of 60. Okay, how do we do that? That's where our calculator comes into play. Okay, so you can do this on Desmos, the free calculator online. I also have a copy of what our TI-84 looks like, so if you have one of these, you can use this as well. Big thing for any type of calculator, whatever you're working with, you want to make sure that you are in degree mode. If you'll notice the third one down, we want to be in degree mode. Okay. Now we're in the correct mode. So notice along here, you have sine, cosine, and tangent. Those are the three trig functions. So we want to type in 11 times cosine of 60 now that we're in degree mode. So let's do that. 11 times cosine of 60 and hit enter, and we get 5.5 for x. Okay. Now, something to think about. Let's talk about our special right triangle rules, just as a quick refresher to see how that works. This is the hypotenuse, and x would be the short leg, right? We know that in a 30, 60, 90 triangle, the short leg is half of the hypotenuse. So 11 divided by 2 would be 5.5. Okay? So we can use trig or special right triangle rules with those. Okay? Now, the next example, we have to use trig. That's not a special right triangle. So let's go through this one. Let's take a look at our angle. Remember, your angle is your reference point. So looking at this angle of 41, we have 4, which is opposite, and we have x, which is adjacent. Okay, so what uses opposite and adjacent? That would be tangent. So we could say tangent of 41 equals opposite 4 over adjacent x. Now, x is not on the top this time. Okay, so I'm going to go through how to solve this problem. And then there's just going to be something that you can remember at the end as far as whenever you have this situation where x is on the bottom. We would have to multiply by x to get this off the bottom. Okay, but then notice we have x times tangent of 41 equals 4. So we've got to divide by tangent of 41. Okay, in order to solve for x. So I want you to think about what we had originally. Originally, we had tangent of 41 equals 4 over x. Now we have x equals 4 over tangent of 41. Notice that the x and the tangent of 41 just switched places, right? So from now on, whenever you solve one like this where x is on the bottom, remember to just switch places with whatever is on the left side, okay? So we want to type 4 divided by tangent of 41 into our calculator. Let's take a look and see what that would be. 4 divided by tangent of 41, and that gives us 4.601. Okay, so we know now that x is 4.601. Okay. All right. Let's take a look at some more. This time we're going to be solving for some angle measures, so it's going to be a little bit different. Take a look at this one. We want to solve for measure of angle A. So angle A is our reference point. We don't have the measure of angle A, but that's still our reference point. Let's take a look here. 9 is opposite of angle A and 12 is adjacent. So again, if you make a quick little note to yourself, okay, opposite and adjacent would be the tangent ratio. So we can say that tangent of angle A is equal to opposite, which is 9, over adjacent, which is 12. Now, if we want to solve for the measure of angle A, we have to do what's called the inverse. Okay, so we're going to have to take the inverse of 9 over 12, the tangent inverse, to find out the angle. Basically, if you look at your calculator, look above the sine, cosine, and tangent buttons. Notice in blue you have sine -1, cosine -1, tangent -1. Those are the inverse functions. What those do is when you type this in the calculator, it's going to give you the angle that has that tangent value. Okay, so we are going to type in second tangent to get the inverse. Notice it comes up with tangent -1. And now we're going to put in 9 divided by 12. So what this is going to do is it's going to give us an angle that has a tangent of 9 over 12. So our angle is 36.86. Let's see. Okay, so the 8 after the 9 means we round up. So this is going to be 36.87. Okay, and degrees because it's an angle measure. All right, let's try example D. We want to find the measure of angle G. I'm going to label that again just for our reference. Let's take a look at what we have. Looking at angle G, 14 is adjacent, 16 is hypotenuse. What uses adjacent and hypotenuse? That would be cosine. So we can say cosine of angle G is adjacent 14 over hypotenuse 16. Now we want to get the angle, so we're going to have to take the inverse. So we want to take cosine inverse 14 over 16. Excuse me. If we do that over here, hit second cosine 14 divided by 16. Hit enter, and that would be, whoops, what was it? I lost it. 28.955. Okay, so 28.955 degrees. All right, so now we're going to kind of put both of those together. Take a look at this one. We're going to solve for everything that's missing. This is called solving a triangle. Okay, so we're going to solve for all of our missing pieces. If we take a look, the first thing listed is AC. Notice we've got two of our sides. An easy way to find the third side, which is AC, is to use Pythagorean theorem. So let's go ahead and do that really quick. So 12 squared minus 6 squared should equal, let's call that x. We'll label that x. X squared. 12 squared is 144. 6 squared is 36. Okay, so next thing we want to do is subtract 144 minus 36. 144 minus 36 should give us 108. Okay, at this point, we have two options. We can leave this as a, excuse me, square root in simplest form, or we can go ahead and get the decimal. I'll go ahead and write out both. 108 is 36 times 3. So if we take the square root of that, of the 36, that would give us 6 and leave the 3 inside. So we've got 6 squared to 3, or as a decimal, let's see what that would be. Okay, oops. 6 square roots of 3 as a decimal would be 10.392. Okay, so 10.392. All right, now let's try the next one. Measure of angle A. We want to find this measure, so I'm going to label that one. That's the one we're looking at, measure of angle A. So looking at A, we have 6 as the opposite side and 12 as the hypotenuse. Now, for one like this, I would not use something that you found. What if you made a mistake? So I'm not going to use the side AC because that's something that I solved for. And what if I made a mistake in solving for that? I want to make sure that I get this correct or that I don't throw the rest of my problem off because of my answer. So let's use what we were given. 6 is opposite, 12 is hypotenuse. We know that sine uses the opposite over hypotenuse ratio, so we can say that sine of angle A is opposite 6 over hypotenuse 12. So in order to get angle A, we want to do the inverse sine of 6 over 12. And if you've been paying attention, maybe you caught what this one's going to be. Okay, inverse sine of 6 over 12 gives us 30 degrees for angle A. So maybe you caught on that this was a 30, 60, 90 degree triangle. Notice our sides were 12, 6, and 6 squared to 3. Okay. We already know that the other angle B, is going to be 60, but I still want to go through and let's talk about how we can use trig to find angles. So let's take a look at angle B. 6 would be adjacent to angle B, and 12 would be hypotenuse. So cosine uses the adjacent over hypotenuse ratio. So we could say cosine of B is 6 over 12. So in order to solve for B, we need to take the cosine inverse, the 6 over 12. So let's go do that. Second cosine, 6 over 12. And that would give us 60. So we already knew that, but now the math proves it. Okay, so 60 degrees. So we can use this to find the measures of angles or sides depending on what's in our triangle. Let's take a look at one more. This time, notice that we are given one angle and one side. So we need to solve for the missing side, 2 missing sides, and the missing angle. The easiest thing to solve for is the one that's by itself. Notice before, the quickest thing to solve for was the missing side. We already had 2 sides. We just needed the third. Take a look in this one. We already have 2 angle measures, the 90 and 29 degrees. Now we want to solve for angle R. That's very quick. Okay, we know that triangles have to add up to 180. So if we take 180 minus 90 minus 29, then we're going to have 61 degrees left for angle R. Okay, so 61 degrees for R, and that's quick and easy to find. Now, I'm going to label these as X and Y to make it a little bit easier when we're setting up our ratios. So QR is our X, QR is our Y. Let's solve for QR, which we've labeled X first. Looking at 29, X is opposite, and 14, which was given to us, is adjacent. So what ratio uses opposite over adjacent? Remember, we can write this out if we need to. Well, that doesn't look like an H, does it? Okay, so opposite and adjacent is tangent. So we can say tangent of 29 equals opposite X over adjacent 14. In order to solve for X, we need to multiply by 14. So now we're going to type 14 times the tangent of 29 into our calculator. And notice this is the regular tangent. This is not the inverse because we're not solving for an angle. We only use the inverse when we're solving for an angle. 14 times tangent of 29. So our angle is our side is 7.760. So QR 7.760. Whoops. Now, let's solve for y. Again, let's look at angle P because that's the one that was given to us. So 14 is adjacent, y is hypotenuse. So cosine is our ratio here. Cosine of 29, remember the angle always goes with the trig function. So cosine of 29 is adjacent 14 over hypotenuse y. Now, we had one like this before. Remember when our variable is on the bottom, we can switch with what's on the other side. So we can say y equals 14 over cosine of 29. Let's go type that in. 14 divided by cosine of 29. And again, it's the regular trig function, not the inverse. 14 divided by cosine 29 is 16.007 when we round. So 16.007. Okay. And then some common sense things that can help you. Oops, I didn't mean to do that. Some common sense things that can help you. Notice that PR is our hypotenuse, so it should be the biggest side, right? And notice that 16.007 is bigger than the other two sides. Okay, some common sense things like that can help you in case you make a mistake somewhere. Maybe you just typed the wrong thing in. A lot of this is calculator heavy. You're typing things into the calculator. What if you leave out a number, something like that, or just type in the wrong thing? Those kind of common sense things can help you make sure that you don't make too many mistakes, or can maybe catch you if you do make a mistake. Okay, I hope that this has been helpful. We're going to work with right triangle trig this week. I'm going to do a lot of solving triangles.